5.6 is the last section that we're going to cover in chapter 5. In this section, we're going to divide polynomials. So, first thing I want to remind you of is to recall how we added fractions. How we added fractions. Listen, if you have two fractions that have the same denominator, then you're trying to add them or subtract them, all you do is add or subtract the numerators and keep the denominator the same. So in this example, okay, right here, we're adding a over c plus b over c. That's any fraction, two fractions that have the same denominator. What do? You add their numerators as it's indicated here, here, and keep the denominator the same. In the next line, I give you an example of two fractions. Even though they're improper fractions, it gets the point across. 10 over 5 plus 15 over 5 equals 25 over 5. Right? Because you're adding 10 and 15. But look at this line down here. Isn't 10 over 5 the same as 2? Isn't 15 over 5 the same as 3? 2 plus 3 is 5. But up here, 25 over 5 is 5. So all we did was take the numerators, added them together, and kept the denominator the same. And it became the exact same thing as if we divided first. If we took this and divided 10 by 5 and 15 by 3. Okay, I'm showing you that because what we're going to do is we're going to take a fraction basically and break it up into two parts, just like it looks down here. Notice down here, let me erase this. Notice here at the bottom in the definition box, a plus b over c, we break it up into a over c plus b over c. So all we're doing is working backwards. We're breaking it up. So what it's saying is if you have two terms on the top of a fraction and one term at the bottom, one term at the bottom, one term at the bottom is a monomial, one term at the bottom. If you have one term at the bottom, then you can divide every term in the numerator by that one term in the bottom. We can break it up into several different parts as long as the denominator is not 0. Example, divide 25x to the third power plus 5x to the fifth power by 5x squared. First of all, you have to understand to divide by a monomial is very, very easy. Is 5x squared a monomial? Is it one term? Yes, it's one term. So in order to divide a polynomial by a monomial, all you do is take that polynomial and rewrite it 25x cubed plus 5x squared over 5x squared. Then you break it up. Break up the two terms at the top, 25x cubed over 5x squared plus, because there's a plus sign between them, 5x squared over 5x squared. Okay? Take a minute, and now we're going to use our rules that we have learned about dividing exponents and all. So let's look at it. 25x to the third over 5x squared. 25 divided by 5 is 5. X to the third divided by x squared is x. Okay? Plus what? What's 5x squared now divided by 5x squared? Remember, anything divided by itself is 1. Well, same thing here. It's 1. So keep in mind what we did. When you're dividing by a monomial, this is something you have to remember. When you're dividing by a monomial, all you do is divide each separate term by that monomial. Next example is the same thing. Divide 8t cubed plus 4t squared by 4t squared. 8t cubed plus 4t squared by 4t squared. Break it up. 8t cubed over 4t squared plus 4t squared over 4t squared. Simplify. 8 over 4 is 2. T to the third divided by t to the second is t. Plus, now 4t squared over 4t squared is 1. And we have just divided by a monomial. So here we go. We're dividing a trinomial by a monomial. The easiest kind of division. Okay? The easiest kind, because all you have to do is separate the trinomial in the numerator. So let's rewrite it. 30x to the 7th over 5x squared plus 10x squared over 5x squared minus 5x over 5x squared. Notice plus and minus because those are the signs that are in the that precede those terms. So let's simplify it now. 30x to the 7th over 5x squared. Well, 30 divided by 5 is 6. X to the 7th divided by x squared is x to the what? 5th. Plus, now, 10 divided by 5 is 2. X squared over x squared is just 1. So all we have is 2 there. 2 times 1 is just 2. Minus 5x over 5x squared. Now be careful with this. The 5's cancel, so those go away. And then you have x over x squared. Think about what that is. Remember, I'm going to go over to the right. X over x squared really is x over x times x. Now what happens? One of the x at the top cancels with one of the x's at the bottom. It leaves you a 1 up there at the top. So we have 1 over x is what this simplifies to. So we just divided our trinomial by a monomial. That's a 1 over x. Let's look at the next one. 16x to the 6th over 4x squared plus 20x to the 3rd over 4x squared minus 12x over 4x squared. Simplify. 16 over 4 is 4. X to the 6 over x squared is x to the 4th. Plus 20 divided by 4 is 5. X cubed divided by x squared is x. Minus 12 over 4 is 3. But when we divide x by x squared, it leaves us an x in a denominator. Okay? Remember, we want to write it with positive exponents only. If you end up with negative exponents, you want to rewrite it so they all have positive exponents. That's why you have to leave that x in the denominator. Okay, here are 2 more examples. Let's rewrite it. So I suggest you rewrite it because if you try to do it all in one step, you may make a mistake. I'm rewriting it by separating the terms. Okay? And now I'm going to simplify each one. Okay, 12 over 3 is 4. X to the third divided by x is x squared. Y to the third divided by y is y squared. Okay, minus 18 over 3 is 6. X and x cancel, so they become a 1, and the y cancel. Right? If I do, oh shoot, that and that, those cancel, and those become 1s. Okay? So, I don't know if I can erase this. I can erase what I just wrote. All right. Okay, so, then 6 over 3 is 2. But what happens with the y's? The y's cancel, right? But you're left with an x in the denominator. So that's the way you have to leave it. The x is positive, has a positive exponent in the denominator, so you have to leave it that way. Okay. Next one, just like it. 15 x to the fourth, y to the fourth over 5xy. Notice we're doing this because the denominator is a monomial. If the denominator was not a monomial, we'd have to do something called long division, which we're going to get to in a minute. So I just rewrote it, and now I'm going to simplify each one. 15 divided by 5 is 3. X to the fourth divided by x is x to the third. Y to the fourth divided by y is y to the third. Minus 10 divided by 5 is 2. The x's cancel, the y's cancel, so it's just 2. Plus, let's see. The y's cancel, so it leaves me a 1 in the numerator, 5 in the denominator, and an x in the denominator. Okay? So this is the simplified form of the expression after you divide. All right. Now, when you have to divide by some polynomial that is not a monomial, meaning if it's not a monomial, not a one-term polynomial that you're dividing by, you have to use long division. You have to use long division when you're dividing by a binomial or a trinomial. Okay? You have to use long division. You have to use long division. You have to use long division when you're dividing by a monomial or a trinomial. What am I talking about? Long division looks just like it looks when you divide numbers. So, let's say you have a division problem here. Okay? Look at this division problem. If you're dividing 17 into 4,125, or you're dividing 4,125 by 17, notice what you do. What are the steps for division? First, you divide 17 into 41. Then you multiply 2 times 17. Then you subtract 34 from 41. Then you bring down the 2. Okay? Then you start all over with division. So the steps are divide, multiply, subtract, bring down. Those are the steps. Divide, multiply, subtract, bring down. The steps are divide, multiply, subtract, bring down. So what do? Divide, multiply, subtract, bring down. Those steps. But before you ever do that, the thing you have to remember is to divide using long division. The expression that's under your division bar, when we're working with polynomials, expression under your division bar must be in descending order of the exponents. Okay? I can't stress that enough. It must be in descending order, and every exponent must be present. Okay? I'm going to explain to you what that means on the next slide. Okay, so when you're dividing and you place your dividend, that's the expression that goes under the division bar. When you place it under the division bar, you cannot have any missing terms, meaning all of the exponents have to be accounted for. So for instance, if you have, say something like 3x to the 5th plus, oh, my pen went out, 3x to the 5th plus 4x to the 3rd plus 2x plus 5. Look at this expression. Identify the exponents that are there. Make sure they are in descending order, and make sure there are no exponents missing. Now what I mean by missing is, notice this expression has a 5 as the exponent. This expression has a 3 as an exponent. Notice there is no 4, no exponent of 4 anywhere in there. So what we have to do is insert the missing exponents. And how do you do that? Well, you rewrite the expression 3x to the 5th plus 0x to the 4th. It may not seem to make sense to you right now, but it's necessary. Plus 4x to the 3rd. So notice I'm inserting the exponents that are missing. What else is missing? Well, we have x to the 3rd, then we have x, which is really to the 1, right? So we are missing x to the what? X to the 2nd power. We don't have an x to the 2nd power. So we'll put 0x to the 2nd power plus 2x plus 5. You only do this when you put the expression under the division bar. I'm not telling you if you come up with an answer that you have to do all of this to insert missing terms. You only insert missing terms in preparation for division, long division, and you only do it with the terms that are under the division bar. Okay? You have to be very careful that every exponent is represented and that they are in descending order. This is the biggest mistake students make with long division. They do not make sure that the terms are in descending order, and they do not make sure that every exponent is represented. You have to put those zeros there. Okay? So let's move on to the next slide, and let's look at what's being asked of us. It says divide x squared plus 12x plus 35 by x plus 5. Well, this means x plus 5 is going outside of the division bar. Let's look at our expression. X squared has an x to the second power. 12x has an x to the first power. 35, if you remember, it has an x. It has an x to the 0 power because x to 0 is 1. We don't write that, but it's understood to be there. So that has a power. Okay? So I'm going to erase it. But all of the exponents are present, and now we can set up our division. Okay, so I'm going to set it up. X squared plus 12x plus 35 is going under my division bar, and x plus 5 is going outside. Let me see if I can move all of this. All right, I moved it. So follow the steps. The steps are divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So what we do is we look at this x right here. We divide x into x squared. We say, forget about the 5 for right now, but look at x and divide it into x squared. So in your mind, what you're saying is, watch on the right of the screen, you're saying, what is x squared divided by x? All right, I'm dividing x into x squared. That gives me an x. So watch what I do. I'm saying this x goes into this x squared how many times? Well, it sounds goofy, but we say x times. Notice where I'm putting it, over the x terms in my dividend. Okay, so I just divided, but when I multiply, I'm going to multiply by 5 and by x. So I say x times 5 is 5x. Notice where I put it, 5x. I'm lining it up with the other x's. Then I say x times x is x squared. That 5x is positive because x is positive at the top. That's positive x, and this is a positive 5. So that's why this is positive 5x. This x now times this x here gives you this x squared here. Okay? Take a minute if you have to so you can understand it. Okay? Now, what's the next step after division? Multiply. What do? Subtract. But you have to be very, very careful here. How do you subtract a binomial? Technically, you're subtracting this whole thing. You're performing subtraction on the whole thing, which means performing subtraction on the whole thing means you change the signs of these two x squared and 5x. You change the signs of those two. So some people, when they're working this type of problem, they know the next step is subtraction. So what they do is come in and just change the sign, change the x squared to negative x squared, change the 5x to negative 5x. This is probably the most challenging thing about long division. So you're changing their signs because that's what subtraction does. Now you go ahead and subtract them. 12x minus 5x is 7x. X squared minus x squared is 0. So we don't have to write that, 0. Now we have 7x. What's the next step? Bring down. What are we bringing down? 35 plus 35. Okay, so we brought down the 35. So we divided, multiplied, subtracted, and brought down. Now we start the division again. X over here, X goes into this 7x right here. How many times? So in other words, we're dividing 7x by x. 7x divided by x is what? 7. So x goes into 7x 7 times. Plus 7, because it's a positive, 7. 7, positive 7 times 5. Now I multiply, excuse me, the 7 times 5. That gives me positive 35. And the 7 times x, which gives me 7x. Okay, notice what's happening here. Next step would be to subtract. Subtract means change it each term. If it's negative, change it to a positive. If it's positive, change it to negative. So these both become negative. So that when you combine them, 35 minus 35 is 0. 7x minus 7x is 0. So there's no remainder. You know how sometimes you get a remainder? We don't have a remainder in this case. And we have completed the division. Now, how do you check division? We have x plus 5 times x plus 7. How do you check it? By multiplying. Okay? You know how to multiply these polynomials now, so check it. Check it by multiplying, so FOIL it right quick. X times x is x squared. X times 7 is 7x. 5 times x is 5x. And 5 times 7 is 35. So we get x squared plus 12x plus 35. So we multiplied it and we've got the exact same thing that we had under our division bar. Okay, so look at the next one. I'm not gonna talk as much. I'm gonna talk myself through it, but I want you to pay attention. So we're dividing x plus 2 into x squared plus 5x plus 6. I'm dividing the x into the x squared. X goes into x squared x times. Now I'm multiplying. X times 2 is a positive 2x. X times x is x squared. I'm going to subtract now, which means change the signs. I have the luxury of changing my colors, so subtraction changes the signs from positive to negative. Then I'm going to go ahead and subtract. 5x minus 2x is 3x. X squared minus x squared is 0, so we don't write that. Now we just bring down the 6. Bring down the 6. So now we start the dividing all over again. So we start with the x. We look at x goes into 3x 3 times. X goes into 3x. We're looking at this x going into this 3x. Okay? And it goes in 3 times. Now we take the 3, multiply by 2. Positive 3 times positive 2 is positive 6. Positive 3 times x is 3x. Next step is subtraction. Change the signs. That's what subtraction does. And then we are left with the remainder of 0. Okay, so now let's divide another one. First, we have to make sure that all of our exponents are represented. We have an x squared, we have an x to the first, and we have an x to the 0. So here, 6x squared plus 7x minus 7 goes under the division bar. Now we're dividing by 2x minus 1. Okay, we have all of our exponents represented. So let's divide 2x. We only divide with the 2x. 2x goes into 6x squared 3x times. Right? That's just saying that 6x squared over 2x leaves you what? 3x. So that's why I put 3x at the top. Then we multiply 3x times negative 1. The negative 1 right here. Okay? So 3x times negative 1 is negative 3x. Notice I'm lining it up under the x's. 3x times 2x is 6x squared. Notice if you do it correctly, your first term down here will always be the opposite, will be the same as the term just above it. But when you subtract, it becomes the opposite. So 6x squared becomes negative 6x squared. Negative 3x becomes positive 3x. So if it's positive, it changes to negative. If it's negative, it changes to positive. Okay? So now you combine them. What's 7x plus 3x? Okay, that gives you 10x, positive 10x. Now 6x squared, right here, minus 6x squared gives you 0. So actually, I don't need that plus 10. You know, we don't have to put that that positive sign there, but I can't erase it. So anyway, now we bring down the negative 7. So we have 10x minus 7. My pen won't erase because of the way the program is. I can't erase this positive sign, but just pretend it's not there. Positive 10x. So 2x goes into 10x 5 times. Plus 5. 5 times it goes in. Now 5 times negative 1 is negative 5. 5 times 2x is 10x. Notice what we're doing. We're subtracting now. Negative 10 plus 5. The subtraction changes the sign. So what we have is negative 7 plus 5 is negative 2. And the 10x minus 10x goes away. So we have a remainder now. Now what do we do with a remainder? Normally, when we work with fractions, we take the remainder, which is negative 2, and we put it over the divisor. But what is the divisor? This expression here. So we put the remainder over the divisor, and that's going to be your answer. So the answer really is 3x plus 5 minus 2 over 2x minus 1. Because this is the remainder, all right? I mean, the negative 2 over 2x minus 1 is the remainder. You leave it that way. All right? Here's another problem. We're going to divide, okay? But as we're placing our dividend under the division bar, let's make sure all of our exponents are in place. So we have a 4x squared. We have an 8x to the first, and then we have a constant term, negative 7. And so it's in descending order, and there are no missing exponents. So let's divide 2x plus 1 into 4x squared plus 8x minus 7. Okay, so we're going to take the 2x here and divide it into the 4x squared there. Okay, so 2x divides into 4x squared 2x times positive 2x. Remember, Where that comes from is we're taking 4x squared divided by 2x, and that gives you 2x. And so that's what I'm putting at the top, 2x. Now I'm going to multiply 2x times the 2x plus 1, one term at a time. 2x times positive 1 is positive 2x. 2x times 2x is 4x squared. Notice that the first term here is always going to be the same as this term up here. That's the goal, so that when you subtract them, you know, the second one is going to change sign, so it'll go away. So now let's subtract. I'm going to change the sign of this to negative, change the sign of this to negative. And now I can combine these two separate lines. 8x minus 2x, 6x. 4x squared, excuse me, 4x squared minus 4x squared, that's 0. So we don't write 0. Now the next step is to bring down the negative 7. Okay? Now we divide 2x into 6x. 2x into 6x is plus 3, positive 3. Now multiply 3 times 1, positive 3. 3 times 2x is 6x. Subtract. So that means change the signs of each term. Remember, if it's positive, it becomes negative. If it's negative, it becomes positive. And now we have negative 7 minus 3, that's a negative 10. And then 6x minus 6x is 0. So we have minus 10 as a remainder. So we put minus 10 over 2x plus 1. Okay, so ultimately your answer is 2x plus 3 minus 10 over 2x plus 1. Okay? Okay, now let's go ahead and divide this one. Now look at the expression and tell me what, well, if you tell me I won't hear you, but tell me what has to be done in order to do this division. Number one, notice that the denominator is not a monomial, it's a binomial. So you know you have to do long division. So we can start setting up the long division. So we're going to divide 3x plus 2 into what? Well, look at the top expression. We have an x cubed term and an x term and a constant term, but we don't have an x squared term. So we have to insert an x squared term. But we also have to write these expressions, these terms in descending order of the exponent. So we're going to start off by writing 9x to the third. We're going to insert 0x squared. All right, and minus x because it is a negative x, and plus 5. Take a minute and look at what we did. Notice that 0x squared does not change the problem at all. It doesn't change the expression at all. 0 times anything is still 0. It's just that it's kind of like a placeholder. Okay, it's like a placeholder, and you have to have the missing terms inserted before the division can be done correctly. Now let's go through the steps to divide. 3x goes into 9x cubed, 3x squared times. Notice where I put it, over the square term, x squared term. If I had never put the x squared term there, I would not have any place to put these terms. So let's multiply. 3x squared times 2 gives you 6, positive 6x squared. 3x squared times 3x is 9x to the third. Next step, subtract, which means change the sign of both of these terms. Negative 9x cubed, 9x cubed becomes negative. 6x squared becomes negative. Then we go ahead and combine. Now look, here you have 0x squared. Here you have minus 6x squared. 0 minus 6 is negative 6x squared. The 9x cubed minus 9x cubed becomes 0. Okay? Now, next step is to bring down the x term. All right? Now notice the first term now here is going to be negative, which is going to affect the sign when you divide. 3x goes into negative 6x squared, negative 2x times. Okay? So I'm going to multiply negative 2x times 2. I get a negative 4x. Negative 2x times 3x is negative 6x squared. Then we subtract. But what happens to the sign now when we subtract? Well, the negative becomes a positive, and the negative there becomes a positive, because subtraction means change the sign. So we have a negative x and a positive 4x, so that gives us plus 3x. Okay, and 0. Negative 6x squared plus 6x squared is 0. So honestly, I don't have to write the plus sign. All I need to do is bring down the 5 and then start dividing again. 3x goes into 3x one time. 1 times 2 is 2. 1 times 3x is 3x. So we subtract. That becomes negative. That becomes negative. Let me change that. That's a little raggedy. That becomes negative. All right. So then we combine. 5 and negative 2 gives us 3. 3x minus 3x is 0. So we have a remainder of 3. So we take that, it's positive, and put 3 over the divisor, which is 3x plus 2. So that is your answer. 3x squared minus 2x plus 1 plus 3 over 3x plus 2. Okay? Now look at this one. All right? We have 3x plus 2 divided into 9x cubed. We have to put them in order, and we have to insert what's missing. We have an x cubed, we have an x, we don't have an x squared, so we have to put 0x squared plus 11x minus 3 in that order. Okay, now we divide. 3x goes into 3x cubed, 9x cubed, 3x squared times. All right, now 3x squared times 2 is 6x squared. 3x times 3x, 3x squared times 3x is 9x cubed. Subtract each term, so the signs change. Then we combine, so we get negative 6x squared again. Then we bring down the 11x. Then divide. 3x into negative 6x squared is negative 2x. Negative 2x times 2 is negative 4x. Negative 2x times 3x is negative 6x squared. But we're going to change the signs now. That's what subtraction does. It changes the sign. Now we combine them. 11x and 4x is 15x. I know the 6x squares are going to go to 0, so I don't have to write anything else. I just need to bring down the negative 3. Now 3x goes into 15x 5 times. 5 times 2 is 10. 5 times 3x is 15x. Subtract, change the signs, and combine. So we have negative 3 and negative 10. That's a negative 13. And the 15x's cancel. Okay? The 15x's cancel. So we're left with negative 13. So we put minus 13 over 3x plus 2. So all of that at the top is your solution. Here we have x cubed minus 8 divided by x minus 2. So we put x minus 2 outside the division bar. But the x cubed minus 8, it's missing some terms. We have a cube term, but we don't have a square term, and we don't even have an x term. So we have to put those. We have to insert. So we have x cubed, 0x squared, plus 0x minus 8. You have to do this, okay? You cannot divide this otherwise. All right? So x goes into x cubed, x squared times. X squared times negative 2 is negative 2x squared. X squared times x is x cubed. So we subtract. This becomes negative, this becomes positive. So we have 0x squared plus 2x squared, that's 2x squared. Bring down the 0x. X goes into 2x squared. 2x times. Now 2x times negative 2 is negative 4x. 2x times x is 2x squared. We're going to change the signs for subtraction. That becomes negative. This becomes positive. All right? 0x plus 4x is 4x. I know the 2x squares are going to cancel, so I just bring down my negative 8. X goes into 4x 4 times. 4 times negative 2 is negative 8. 4 times x is 4x. When we subtract, 4x changes to negative, 8 changes to positive. So we don't, oh shucks, I wanted to erase. We don't have any remainder now. Okay, this becomes 0, so we don't have a remainder at all in this situation. Okay, so our final quotient is x squared plus 2x plus 4. Here's one more. All right, we're dividing x cubed plus 27 by x plus 3. We have to use long division because x plus 3 is not a monomial. So x plus 3 divided into this, but we have some missing terms that we have to insert. X to the third. What else do we have to insert? 0x squared. What else? 0x. And then the constant is 27. All right, x goes into x squared cubed, x squared times. X squared times 3 is 3x squared. X squared times x is x cubed. We're going to subtract and subtract. All right, so 0x squared minus 3x squared is negative 3x squared. Okay, the x cubes are going to cancel. I bring down the 0x. x goes into negative 3x squared, negative 3x times negative 3x. Negative 3x times 3 is negative 9x. Negative 3x times x is negative 3x squared. So when I subtract, the signs change. Negative 3x squared becomes positive, 9x becomes positive. Okay, 9x becomes positive. All right. So what do we add? 0x plus 9x is 9x. Negative 3x squared plus 3x squared is 0. So all we do now is bring down the 27. X goes into 9x 9 times. 9 times 3 is 27. 9 times x is 9x. So when we subtract now, the signs change, and we end up with a 0 as a remainder. Okay, now that's long division. Go back, practice this. It's not as hard as we like to make it. You just have to remember when you do long division, and you have to remember what to do when you do long division. Okay, talk to you later.